Alright, so this is the solution to the homework assignment in day 5. Admittedly, it was kind of a doozy. Hopefully you're able to figure it on your own. If you got a little bit stuck, that's okay. That's what this video is for. Only watch enough of it to get you unstuck. Or, if you really need the hand holding all the way through, that's fine. But you might want to review all the videos from today just to make sure you have these concepts cemented, solidified in your mind. Okay, so again, we were called upon by the MRU to create an analysis project, and it had to follow this basic UML. So we knew that we'd have an abstract base class, and we'd have 3 derived classes: psychic, physical, and elemental mutant, respectively. We also know that the mutant class would need to implement the iDisplayable interface. Finally, we were going to have to write some code in the program.cs file in the main void that would display all of the information by calling that display info method on each of the instances of our mutants. Okay, so let's see how I went about solving it. Hey, if you went about solving it a different way and you got close to the same thing that I did, more power to you. That's awesome. I think that's great. We can probably learn a little bit from each other in this regard. So, I don't think there's one right solution. Let's start off with the mutant base class, since that seems to be where all the action's at. First of all, you can see that I created a class called mutant. I adorned it with the modifier abstract, and I created a method header called danger quotient, again forcing each of the derived classes to implement that danger quotient method on their own for their own specific situation. That danger quotient method was there to calculate the danger quotient per the rules that I gave you in the video and in the documentation for this homework assignment. All right, but there were also some properties here that we implemented. As you can see in the mutant abstract base class, we had code name and level. And here we define those as those auto-implemented properties for code name and level. Okay, and then finally we implemented iDisplayable. Let's take a look at iDisplayable for one moment. iDisplayable simply defined a contract that says if you're going to implement me, then you need to implement display information. So since mutant implemented the iDisplayable interface on our diagram, what I did in code was go over here to the mutant.cs. You can see here I'm implementing iDisplayable, and I used that fancy little technique where I implemented the interface. It popped open the stub for this method, and then I just wrote this console.write line. And so then I used code name plus danger quotient to string. So even though it's abstract as defined here, you can still use it. And what will happen is on the derived classes, it'll use their implementations of danger quotient in order to fulfill that particular requirement for the console.write line. Okay? Notice here that I didn't use that fancy string formatting syntax. I forgot. Sorry. Maybe yours looks a little bit cleaner than mine. All right, so then let's take a look at each of the of our classes that derive from the mutant abstract base class. So let's start off with psychic mutant, and here all I did was add 2 additional properties, and then I overrode the danger quotient using that formula that we described in both the video and in the requirements document. It's as easy as that. And each of the 3 classes that implement mutant or derive from mutant have the same basic format. So if we take a look at physical mutant, same idea. I just implemented the extra properties as defined in our diagram, IQ and strength in this case, and then override the danger quotient, and then I return that calculation that we defined. And finally, elemental mutant looks exactly the same. Just added a region and created our own version of the danger quotient. All right, so then the final piece of this was in the program.cs, and here you can see I'm creating a generic list of mutants called mutants. All right, and so then I start creating all these instances. I create 2 psychic mutants, Mindbender and Svengali. Then I create 2 physical mutants. One's called Strongman and the other one's called Biggie. And hopefully I have not infringed on anybody's trademarks or so forth. I try to stay pretty generic. It's kind of hard to. There's like 1,000 characters in the Marvel Universe. Not all of them are winners. Elemental Mutant, Fire Dude, and Rain Girl, and implemented their properties. Okay. Then, in each case, I added them to that mutants collection, which is a list again of mutants. Again, here I'm just using that base class, passing that in as the generic type that we're going to set our list to. Then it's as easy as doing a for each loop, grabbing each mutant in our mutants list, and calling the display information. So let's see what happens when I run my application, and that's what we get. And I think the key notion here is that display information. That was probably the hardest part because that's what we spent the least amount of time talking about. How when you implement something like this in the base class, you can still reference abstract methods, and you're going to get the implementation of that method regardless of the derived class. And that's what I relied on here for that. All right, so I think that pretty much does it. Hopefully you got close. If not, take some time and go through this example. Try to do it without my help, based on now what you know. And then try it again, and you can watch if you need to and follow along. That's a good way to learn. All right, so that concludes day 5. Boy, this was an important day. We covered a lot of important topics. Tomorrow, we're going off in a completely different direction. We're going to actually get out of C# for a little while. But it's a skill that you absolutely need, and that's working with databases. So we'll see you in the next video.